So far, I have been focusing on normal distributions in our discussion of z-scores, or distributions that we use in statistics. But not all distributions are normal. Let me show you a different theory that applies to all distributions, not just the normal distribution. Let's begin by reviewing the empirical rule. In a normal distribution, 68% of all scores will be within plus or minus 1 standard deviation, 95% of scores will be within plus or minus 2 standard deviations, and 99% of scores will be within plus or minus 3 standard deviations, giving us the 68, 95, 99 empirical rule. But not all distributions are normal. What if we had a highly skewed distribution, or a kurtotic distribution, or a bimodal distribution? Obviously, 68% of the scores would not be within 1 standard deviation above or below the mean if our distribution was highly skewed. Therefore, we want to look at another theory called CHEBYSHEV'S Theorem that tells us some important factors that apply to every distribution, not just a normal distribution. CHEBYSHEV'S theorem tells us that at least 1 minus 1 over z squared number of items in any data set will be within z standard deviations of the mean. Z must be a value greater than 1, but it does not need to be an integer. So for instance, CHEBYSHEV'S theorem would work with values such as 1.5 or 2.36 standard deviations. This is CHEBYSHEV'S theorem. 75% of data values must be within 2 standard deviations of the mean. 89% of data values must be within 3 standard deviations of the mean. And at least 94% of data values must be within 4 standard deviations of the mean. Let me illustrate CHEBYSHEV'S theorem, as well as the empirical rule, using a data set. We will have one data set that is normally distributed and another which is highly skewed. And we're going to see whether or not the empirical rule and CHEBYSHEV'S theorem hold up for these two data sets.